Hello and welcome to the Video Academy. In this video we'll be looking at BridgeTech's new feature, the Gold Transport Stream Protection. But first I want to start by explaining the need for GoldTS Protection. It complements existing ETR290 monitoring by going much further than this test. Let me explain. An ETR290 engine will test the MPEG transport stream against the ETR190 standard, and it will generate errors depending on how the user has set up the alarm template. A BridgeTech probe can, if required, monitor all priority 1, 2 and 3 alarms. If, for example, the NIT other table suddenly dropped out, then the ETR engine will register this fact and generate the appropriate alarm. These show up in the probe GUI, and the probe can supply very detailed information about this error. But what if the error is a bit more subtle? Let's take a look inside the NIT. Imagine, for example, we're downlinking several transport streams from a provider. The provider changes, for whatever reason, a service ID. He changes service ID 8206 to 8156, but forgets to tell his downstream customers. ETR290 checking will not notice this, as there is actually nothing wrong with the NIT. We need some other tool in order to find this problem. Let's see another example. Here's a capture of a transport stream, and if we look at the second audio PID 106, we can see that its audio type is flagged as visual impaired commentary. If PID 106 just disappeared, then it would still be referenced in the PMT, and ETR290 testing would generate a missing PID alarm. If, however, PID 106 lost its descriptor, this would not generate an ETR290 alarm. However, because this PID carries supplementary audio information, this may cause the set-top box to malfunction, and it would certainly impair the end-user experience of this service. This lack of alarm might mean that the error goes unnoticed until viewer complaints arrived. Once more, some other testing is required. This is where GoldTS Protection comes in. In essence, it works very simply. We take a snapshot of what we consider to be a reference stream. All this means is that the transport stream we are referencing is, to all intents and purposes, correct. We use this reference stream to measure the incoming transport stream against. The user can configure which tables he wants to be tested, and any deviation from the reference stream will generate a GoldTS alarm. A few clicks will show the operator exactly where the error is and what the error is. In order effectively to monitor a transport stream, it must be assigned full-time to an ETR engine. Round-robin testing is not appropriate for GoldTS Protection, as the transport stream being monitored spends some of its time unmonitored. Transport streams from any probe input may be monitored, and multiple transport streams can be monitored, each using their own unique GoldTS reference stream. Okay, so much for the theory. Let's see how you do it in practice. Let's use this DVB satellite probe. The first thing to do is to establish which transport stream is going to be the reference stream. I'm going to choose the Thor-1 West stream, which is being received in a VB272 satellite receiver interface. You can see that the GoldTS alarm bulb is present, but it's greyed out, indicating it's not currently configured. If we look at the SAT2 tab, we can see the tuning list shows that the current ETR threshold is the default threshold and that no reference threshold is currently configured. So I'm going to use this stream as it's being received now as my reference stream. I go to the GoldTS Threshold tab. The first step is to add the threshold. I can choose to create a threshold for the currently tuned stream or all streams. And then I select the input I wish to use. As you can see, I'm offered all of the interfaces currently configured on this probe. Obviously, I'm going to pick SAT2. Then I just generate a threshold. There's the threshold now, and if I want to edit its name, I can do so here. I'm going to call it Thor GoldTS. As you can see, the GoldTS reference stream that we've just captured has been automatically assigned to the satellite transponder. I'll need to come back here in a moment to reassign ETR thresholds, and I'll explain why now. Click on the ETR290 tab and then the ETR thresholds tab. As you can see, we currently have a range of thresholds here, but we're using the default threshold. I can't edit the default threshold, and in any case I want to create a unique threshold for this stream. So I'm going to duplicate the default threshold and I'll give it a new name, Thor Gold. We can see now that we have a new section in the threshold configuration called GoldTS Check. It's currently disabled, so I'll enable it, and now I can select which tables I want to monitor. I'm going to add the NIT tables. So we now have a new ETR threshold called Thor Gold, and you can see it currently has 0 references. I need to go back to the tuner card and assign this new ETR threshold to the Thor 1 West frequency, as I would any ETR threshold. We can see from this table that the ETR threshold and the reference thresholds show our new selections. Going back to the ETR290 tab, we can now see that the GoldTS bulb is green. Clicking on this will show me the monitoring that is now being carried out. Looking at the ETR overview page, if we consider the SAT1 input, it's easy to see why it's necessary to dedicate an ETR engine to GoldTS Protection. SAT1 ETR engine is monitoring 3 transponders, and in order to guarantee protection, the transport stream must be continuously monitored. In the case of SAT1, each stream spends 1/3 of its time being monitored and 2/3 unmonitored. Okay, let's see an example of what a GoldTS error looks like. In this error display, we're looking at a PMT. If you follow the tree structure down, you can see that this error was caused by the language descriptor changing from Norwegian to German. This is a very subtle change. And as we've seen earlier, this type of error can only be discovered using GoldTS Protection. ETR Protection alone will not find this sort of error. This concludes our detailed look at the new GoldTS Protection feature in BridgeTech probes. It's an invaluable tool for ensuring transport streams from any input source are constantly monitored for deviation from the reference stream. It detects TS errors impossible to see by other methods. It's perfect for monitoring long-established streams, and it's essential for system setup events like adding new services or muxes. GoldTS Protection requires the full-time use of an ETR engine, and it also requires new hardware 4 probes. Well, thanks very much for watching this video from the BridgeTech Video Academy. I hope you've enjoyed and it's been useful. Why not check out one of the other videos on this page? And if you have a suggestion for something you'd like to see here, drop me a line at training@bridgetech.tv.